Okay, so now let's start moving towards finding a way for our feedback system to use the voltage-controlled oscillator to generate a signal that nearly matches the input signal. So we want to find a way to reduce that phase error down to 0. So to do that, let's continue thinking about the fact that we have something that we're approximating as an LTI system. We're approximating it by using this small angle approximation, right? So this is an approximation for small angles, less than maybe 30 degrees or so. And for an LTI system like that, you put an impulse in, and the output will be the transfer function that you put of the system. So if the incoming signal mismatches our VCO frequency, right? Our VCO frequency is omega C. We receive some mismatch at the input. We want to figure out some way that our VCO instantaneous frequency could match our input, and we're going to do that using phase. Now, we should be able to generate that same frequency and that same input phase from the VCO. We should also note, though, that the VCO, as it generates that phase, it's going to be shifted by exactly pi half. So it's going to generate the same frequency, and then it's going to generate the same phase with an exactly pi half shift added to it, due to the way that the VCO works as the sine integrator, right, where we have the difference, the sine and cosine. That integrator is always going to turn sines into cosines or cosines into sines, which are pi half shifts from each other. So this was the input signal. It has some frequency omega 0 and some phase omega 0 that mismatch the VCO frequency, and we're going to try to figure out how we can make that VCO using the feedback loop give us that frequency. Okay, so if that incoming signal redefined with VCO frequency, this will aid in the comparison. So what would the incoming phase be to create that relationship to omega C? Well, based on the phase error, we know that the phase error should be the input minus the output, and we're trying to make this go down to 0. So if we try this as the phase, so if this is the input phase, then we can substitute this in and multiply this through, and we can see that this would return the original signal with the same frequency and phase mismatch. So we're going to use this as our input phase, and we're going to try to figure out how we can get this error in the phase between the input and the output, the VCO output, to be equal to 0. So what we know now is that the incoming signal has a mismatch from the VCO, has some different frequency, some different phase. We know that the incoming phase can be rewritten like this, so that the incoming signal can be written in terms of the VCO quiescent frequency. And so this is what our situation looks like, and we're trying to figure out how we can get this minus this to be equal to 0. So we want there to be 0 error here.